4 cases, and if our absolute function is less than 0, greater than or equal to 0, less than or equal to 0, and then greater than 0, we have here the solutions. What will be our solutions here? This one is true only if this one is 0. If we have number here, then it will be different. If our absolute function is less than 0, there is no solution, because for absolute function, it is always positive. How can we have a negative here when this absolute function means we remove the sign regardless of its sign? It's always positive. So when you encounter this one, which is less than 0, there is no solution for that. Okay. If our absolute function is greater than or equal to 0 again, so we have all real numbers. 3. If the absolute function of x is less than or equal to 0, then we have only one solution for x, and that is 0. Now, last one is if the absolute function of x is greater than 0, then we have all real numbers except 0. Okay. When we encounter this one plus less than or equal to, this one will be used the end, meaning our diagram will be like this. This and this. This one's going there and this one's going there. For the gray less than or equal to, we have the shaded, and then this one's going there, this one's going there. Usually this portion here will be the solutions of our inequality, or the absolute value inequality. And then we can write our solutions like x greater than, equal to, or greater than only to this number here, and then that x is less than or equal to the number here. Usually this is our solution, but not always. Okay. For B, if we have a greater than and then greater than or equal to, we have the G here, and we are going to use the OR. So that's why it's G, OR, and just put the E there, GOR. The other one, for less, we have the L, and the A and D, we have the LAN. So you can easily remember, if that is less than, then N. If that is greater than G, it's an OR. So you have this one. Now the diagram for greater than or equal to is like this. This portion here, class, the values here are not included. Like this one, the values in between these numbers here are not included. So when we do the solution, it's better to write our solutions in interval notation. It's like negative infinity to the number here. If that one is shaded, then you have a bracket. And then you skip U, or combine with this number here. So what is the number here? That one here. Shaded, that's why it's a bracket. Until the positive infinity. Okay, let's have number 1 for this absolute value inequality. And I will show you the concept of the absolute function. This one is a symbol of absolute function, and really it means distance. So we have the number line here. What do you mean by this distance? It means it's the distance from the 0 of our line number. Distance to the right and distance to the left. That is the general concept of our absolute function. So for number 1 here, less than 4. So we locate the 4. 4 units to the right of 0 and 4 units to the left of 0. So this is our 0. It's 4 units to the right. So this one is our 4 units from the right. And we have also 4 units to the left of our 0 here. And we have this one here. This one is unshaded, the other one is also unshaded because we have only less than. We don't have the equals. When we have the equals here also, then we shade this one, we shade that one, meaning they are included in our solution of the values of x. So we have that one. So x must be between -4 and +4. But 4 and -4, they are not included. So the values of x must be here, somewhere here, or somewhere here. But not 4 and -4. Could be less than 4. Should be greater than 4. You're not going here. You are going to the right, you are going to the left. Okay, let us solve. When we solve absolute function inequality, we will leave the absolute function alone. So if there is a 2 there, -3, we just remove it first and leave the absolute function alone. So in this case, class, our absolute function on the left of this one is already alone, 1 only. So just like this one, we remove this one. When we remove this one, remember that we have positive here and we have negative. So when we remove this one, x here, same thing, this one is 4. This one is the positive. We don't change because this one is positive. The other one will be negative. For the other one, it will be like this. X, when we turn it to negative here, what do you remember about our solution of inequalities? If we multiply it by a negative or we divide it by a negative number, then we change the orientation of our inequality. So the less than now will become greater than, because we multiply this by a negative sign. We change the sign, then we change the orientation. This one we don't, because this one is the positive. This one is negative, then we change. Don't forget that. Okay? Now, so the value of x here is less than 4. So it's not less than 4 inequality. 4 positive here, less than. So we have a less than here. What about the other one? X is greater than -4. Greater. So greater is going to the right, less than is going to the left. So from here, the value here will go to the right. So our value will be like our x here will be this one here, greater than, see, x greater than -4, but x is less than 4. And this is our solution for this number 1. Number 2, we have absolute function of 3x is greater than or equal to 12. So here, the 12 is here. 12 is here. Actually, that is the range of our solution. 12 and 12 here. This was -12 and 12. 12 units to the right, 12 units to the left. And this -12 can be included in our solution. This one also can be included, but we are not sure if they are really included. We need to solve for this one. If that one is x only, then we have x is greater than -12 and x is less than +12 if that is x only. But we have a 3 here. So we need to remove this one. When we remove the absolute function, there is a positive there and there is a negative there. Once you use the negative, you change the orientation of the inequality. So here, I'm going to remove the absolute function symbol. Okay, I'm going to do first the positive. So here, this, so it is still positive. Where's the other one? So if I forget, so we have 3x here. Now, because the 12, I'm going to use the negative, the 12 will become negative. What happens to the orientation of the inequality? From greater than, equal to, it will become less than or equal to negative 12. So, take note of the orientation of the inequality. We change it only when we change it or multiply it by a negative sign, negative 1 if you like. Then we solve. Here, let's let our solution or the simple operation cancel. We have x is greater than or equal to 4. So that is not 12 anymore. It's like that you did somewhere inside the 12, the negative 12. So 4, where's the 4? Let us say that this one is the 4. Then I'm going to put circle here, shaded here. What about the other one? Okay. So divide this by 3. We also divide this by 3, cancel. So x here is less than negative 4. Okay, I put the negative 4 there and positive 4. Plus this one is positive 4, this one is negative 4, and then I'm going to shade this one also. To the left of 0, negative. To the right of 0, positive. Okay? So we have this one. So our x here is less than or equal to negative 4. Equal to negative 4? Yes, we have the negative 4 here. But the value is less. So meaning, where are we going? Are we going to the right or to the left? Less means going to the left. So the value of this one is going to the left because it is going lesser and lesser until negative infinity there. What about this one? X is greater than, we have x is equal to 4 already here. What about greater than? Where will it go? It will go to the right because greater means you go to the right of the number line. So this one is going in this direction. Therefore, this portion here from negative 4 to positive 4 is not our solution. So we can write that one in interval notation. How do we write that one in interval notation? So in interval notation, we start here with the negative infinity and then up to here the negative 4. Is it included? Yes. Then we use a bracket. Then we skip this one. We combine and start again with the 4 here. Going to be positive infinity. Always. Parenthesis here. And this is our solution for number 2. All real numbers except negative 4 to positive 4. That is our solution for number. Okay, let's have number 3. We have our absolute function is less than 11. Meaning our function is less than 11 and greater than 11 on the left. Both 11. Okay, let's solve this one. When we remove the absolute function symbol, this, then we have, okay, now we will have here the positive and the negative. So let's have the positive. When we use the positive, it is still positive 11. Orientation of the equality is same. because we use the positive. When we multiply it by negative here, so it will become 4x plus 3, negative times 11 here, it will become negative 11. When we multiply it by negative sign, what happens to the orientation? It will change its orientation, and now it is greater than. Then we solve these two inequalities. So let's solve this one. We have 4x 11 minus 3. The same thing as if we it's the same thing as solving linear equation. We subtract 3, we subtract 3 also on the other side. So here we have 4x less than 11 minus 3 is 8 over 4 over 4 cancel. X is less than 8 over 4 is 2. So where is that one? Here, let us say that this one is our 2 and that one is like that. Okay, let's solve for this one. So we have 4x and then it's a transpose. Minus 11 minus 3 minus 3 minus 3. So 4x is greater than negative 14 over 4 cancel, and x is greater than negative 3.5. Okay, where is that negative 3.5? So negative, for example, this one is negative 2, negative 3. So let us say this one is negative 3.5. We'll remove this one please. So greater than means this one is going there. This one is less than, meaning. So the solution for our absolute function inequality is our x lies here. So x is greater than negative 3.5 and less than positive 2. So when we write that one, we have x greater than negative 3.5 without equals here and less than 2 here. Okay. Can this line continue here? If you are going to check, better to check or better to test. So is 3 here included here? Let's test this 3 here because this one is 2. So 3. Put in the original equation. So let's start here. 4. Put the 3 plus 3 is less than 11. So 4 times 3 is 12 plus 3, 11. So 12 plus 3 is 15 absolute. 11. But 15 is 15. Is 15 less than 11? No. So really, from the right or positive 2, they are not included in our solution. What about them here on the left of negative 3.5? Are they included? Let us test the negative 4. Because this was negative 3.5, the next number will be negative 4. If you want negative 5, so negative 4. So here 4, we test the negative 4, which is on the left of the negative 3.5 plus 3 is less than 11. This one 4 times is negative 16 plus 3 less than 11. Negative 16 plus 3 is negative 13. This less than 11. We remove the absolute function symbol, this becomes positive. 11. Is 13 less than 11? No. Therefore, our answer is that one. X is greater than negative 3.5 but less than positive